Hello everyone and welcome to another video. Today I'd like to talk about making movies and animations in Matlab. As you know, Matlab is a great tool for visualizing data, and several of our previous videos have talked about generating static 2D and 3D plots in Matlab. If you haven't had a chance to view those, I would recommend taking a minute to step back and go through those tutorials first, as we're going to be building off some of the content we discussed in them. I'll leave a link for those videos in the description below. That being said, why don't we take a minute and briefly talk about animations and movies from a theoretical standpoint before jumping into Matlab. As I'm sure you know, a movie or animation is just a series of still images shown one after another. If you show these images together in rapid enough succession, the brain interprets this as fluid continuous motion. So, for example, I've made myself this crude flip book to illustrate this fact, and you're going to have to excuse my horrible drawing. I'm not much of an artist. In fact, here's a picture that my daughter recently just did in kindergarten. You know, if you look at these two, I kind of think she did a better job than I did. My only saving grace is that she told me that this was supposed to be a giraffe. But anyway, that's sort of beside the point here. So if I flip through this book here, you can see a movie of what I was trying to illustrate here. So I'm trying to make a movie. This is supposed to be a dog catching a biscuit in his mouth and then wagging his tail here. Yep. So again, if you flip through this a couple times, you'll get the idea here that I'm just displaying a whole bunch of still images one at a time here, and it sort of looks like animation here, right? So, oh, hello. What are you doing here? Oh, I see. You're looking for this? Okay, so here, no, sit. Okay, let's try this. Okay, let's try throw. Oh, wagged. Well, okay, that was a real thing. I don't know. Did it look anything like my flip book here? Catch the biscuit and then wag the tail. I don't know. Okay, anyway, let's go ahead and take another step with this idea. All right, so what we saw here was that animation in Matlab really follows a workflow which is similar to that of creating a flipbook. So the first thing that we want to do here is go ahead and, you could run a simulation or otherwise generate data, right? That's the first thing you want to do here is just figure out what is the data that's going to drive this simulation or this animation here, right? So the next thing that you're going to want to do here is once you have all that data, the second step here is, well, we need to start building our flipbook here. So I just need to draw or render the scenario and make one page of my flipbook here. So step 2 is to, draw/render the scenario at some time, maybe let's call it TK, right? Once you have that, we saw that, all right, I've got the one single page of my flipbook done here. The next thing I want to do here is I want to start saving this here. So I'm going to want to go ahead and take a snapshot of the scenario. So I'm going to save my single page of my flipbook. Once I've got that here, I just want to basically repeat here, right? So the next thing here is I want to go ahead and advance time to TK plus 1, right? And then we're just going to basically go back and repeat step 2, and we're going to keep going through building one frame or one page of my flipbook one at a time and saving it to the larger flipbook here, right? Which was where we were going to take that snapshot. Once I've done this and drawn all of my frames of animation, what I can lastly do here is go ahead and save the movie. Okay, so at a high level, this is the outline or the way that we're going to go about tackling this. So what I'd like to chat about now is maybe a couple of Matlab functions that might be helpful at each one of these steps here. So let's start here at step 1. This is pretty easy here, right? Generating the data here or running some kind of simulation. So maybe you've got some fancy flight simulator work which will run a scenario and kick out all of this data and save it to a file here. So all you need to do here is just basically load that data in, right? So load is probably going to be helpful here. If you're familiar with Simulink here, you know that you can run a Simulink model from a Matlab script to generate data here. This is very helpful. You could use the sim command to do that. Again, we've got a video here discussing how to interact between a Matlab script and a Simulink model here. I'll leave a link for that in the description as well here. But again, step one is just about getting the data that you are trying to animate into your Matlab workspace here. So once you've done that here, how about drawing or rendering the scenario at a given time? Well, you see, this is really just talking about plotting, right? All you're doing is plotting or drawing one single frame of your animation here. So just use any of the plot tools that you're already comfortable with, right? Plot, plot 3, surf. Any of these other plotting commands that we talked about, you're basically just trying to make one page of your flipbook here. A couple of things that might be helpful, as you can probably imagine, is you're trying to generate a complicated animation or a complicated scenario. You're probably going to want to put the hold on, right? That way you can draw multiple plots on the same figure. One thing that we're going to see later when we go over to the computer, though, is if you think about this long enough, because this plotting command is jammed inside this for loop here, you're going to want to have to periodically wipe the slate clean, right? Every time you come through this, you want to be drawing on a new blank sheet of paper here, or a blank figure. So you're probably going to want to use CLF, which stands for clear the figure here. And again, we'll take a look at exactly how to implement that here in a second. I just want to put some of these commands up here so we can see. All right, step 3, take a snapshot of the scenario. Once you've drawn your one page of the flipbook, we want to grab that frame and save it into the larger flipbook here, right? So Matlab has a great function for doing that. It's called getframe. Okay, and then we're going to go ahead and advance time. Like we said, if you put this inside a for loop or a while loop, this step is automatically going to get handled for you here. Although maybe we should point out here that if your data that you're simulating here is very temporally tightly spaced here, you might have tons and tons and tons of data, thousands of points of data here, right? You might not want to draw every single plot here of every single point, because that's going to be a very dense movie. So here you might want to think about implementing some logic that maybe skips every other or every 10th frame, or every only draws every 10th frame here, so you don't have such a large movie here. So I'll let you think about how to implement that logic here. Some functions that might be helpful. Matlab has a continue operation that might allow you to skip parts of a loop if you're not interested. And then finally coming down here to saving the movie here. So to save the movie here, you're going to use the VideoWriter class, as well as we're going to probably end up having to use the write video function. Okay, so again, that's the outline of our workflow, as well as some commands here that are going to help us put this together into a cohesive functioning script here. Before we jump over to Matlab here, maybe let's talk about an example that we might want to animate here. So let's take a look at how about trying to animate a trajectory of a point here. So let's say I've gone ahead and run some simulation, or I have some thing which generates the trajectory of some point in space here. So the position vector that describes where this point is located at any given x, y, and z location at any given time t here. Let's say this is something like, I don't know, 5 cosine of t, 2 sine of t, and t here, right? And this is for the ranges of t in the range of 0 to 2 pi. Okay, so this is how my particle is going to move through space here. And if you look at this long enough, you see that what this basically describes is the particle moving in this upward elliptical single helix, right? So if we wanted to sketch out what we think this should look like, let's just briefly draw this here. So you got x, y, and z here. I think when time t equals 0, maybe let's do this in red here. Right, when time t equals 0, the particle starts out here at the point 5, 0, 0, right? And then as t goes up to 2 pi, we see that it spirals up in an ellipse with semi-major axis 5 and semi-minor axis 2, and basically comes up like, again, I think I'm not the best artist. I think we evidenced that by looking at my flip book here, but at the end of the day, I think where this particle ends up here is at 5, 0, 2 pi, right? So what we would like to maybe animate here or demonstrate here is, why don't we try to draw this trajectory, but then it would be awesome if we had a dot or something like that representing the particle, and then this particle would be able to move up this trajectory in time and then eventually end up at the ending location. So that would be really neat if we could see that actually happen in Matlab. So If my flipbook didn't give you nightmares and you still want to continue on, why don't we jump over to the computer and take a look at how we're going to implement this in Matlab. All right, so we just got ourselves a blank script, so let's go ahead and get started. So let's just go ahead and say that we're trying to illustrate animation and movies in Matlab. So let's go ahead and do our normal clear CLC, close all. And now all I need to do is just walk through our 5-step process here, right? So we said step 1 here was generate data here. And we said for our example, we said time was going to go from 0 to 2 pi, and let's use 100 points to do that. And the x points were going to be 5 times cosine of t, I believe. Y was 2 times sine of t, and z was just going to be t. All right, so there's step 1. Again, if you had a more complicated scenario, like having to load in information from an external source or run a Simulink model, that's where you could easily do that. But now, once we have all of the data, step 2 is basically just draw/render the scenario. Right? So let's go ahead and start ourselves a new figure so we can draw on something here. And now I'm just going to start a for loop from k gets 1 to length of t. And then what I need to do now is in here is first, let's just go ahead and extract the data at the current time. So in other words, I want to get t sub k being t sub k, and I'm going to make another variable called xk, which is going to be x of k, and yk is going to be y sub k, and zk is going to be zk. Okay, so there we go. That's the current location of this particle here. So why don't I go ahead and plot the current location of the particle. Okay, so I'm just going to go ahead and use my usual plot3, and I'll just plot xk, yk, zk. And let's make this a green circle here that is a little bit larger. So I'll make the line width 3 here, and I'll make the marker size maybe 15, just so it shows up a little bit more. And now what I also want to do here is I want to draw more stuff. Like, for example, I want to draw the curve here, or the entire trajectory here. So let's go and say plot the entire trajectory, right? So what I probably need to do here is, since I'm plotting multiple things on the same figure, let's turn the hold on. Okay, and then we will go ahead and say plot 3 of the entire trajectory, right? X, Y, Z here. Let's make it a black line here, and we'll maybe make it a little bit thicker here. Okay, great. All right, there we are. And what we can do is we can continue decorating the plot if we want. So for example, we could go ahead and say things like we can turn the grid on. Let's make the X label say X, the Y label say Y, the Z label say Z, and then maybe the title of the plot can be, how about the particle at time equals, let's make this, let me wrap this thing in an entire string here, num to string of tk seconds. There we go. Okay, and maybe let's also let's set the viewpoint. I think we talked about the view here, so I'll specify an azimuth and elevation so I can rotate the plot to be at a very specific location. Okay, so this looks pretty reasonable. Why don't we go ahead and save this script? And I'm just going to go put this here in some temporary location here. Maybe I'll call this thing animation demo. Okay, and let's go ahead and try to run this here. And what I would love to see here is a circle moving up a trajectory or this curve here, but it's actually not going to work. So for example, if we run this thing, we're going to run into a couple things that we might notice. Oops. Oh, sorry. This should be line width, not just width. Sorry. Okay, let's try that again. There we go. Okay. All right, that sort of didn't work. So one thing that we notice here is it plotted all of the points here. So we notice here that because we had this hold on and we just kept plotting and plotting and plotting and plotting, one of the things that we probably need to do here is let's make a change here. Let's go ahead and wipe the slate clean. So we are plotting with a blank figure. So I'm going to go ahead and put a CLF at the very top at the beginning of the loop here, so that when this comes in through, it's going to clear the figure here, and we'll just draw only what we want to draw on each page. So if I do this, again, this didn't seem to quite work. If you notice here, it just ended up drawing the very last image here. I wanted to have seen this particle moving up and up and up the spiral. The reason why it did this here is because MATLAB actually by default here is if you look at this, you notice that our plotting commands, all of this stuff is buried inside of a for loop. MATLAB is actually kind of smart, I guess, in this scenario and realizes that it is going to slow way down if it has to draw every single image here in this for loop. So it actually suppresses the plotting until you drop out of the for loop, and then it will basically render the very last scene here for you. So that's not really the behavior that we want here. I really want to maybe just check to see if this animation is working properly. So what I want to do here is I want to force MATLAB to draw the image at this point here. So what I can do here is MATLAB has this cool function called draw now here. So if you just put a draw now in here, it's going to force MATLAB to flush the graphics and plot this as it goes. So if I do this now this is looking reasonable, right? You see this thing moving up and yeah, our trajectory is going. And MATLAB is actually going to draw it as fast as it can here when you call the draw now. The other option here is, let me comment that out and just show you another way to do this. You can also use the pause command. Pause, if you give it a number in here, it will basically pause the script for however many seconds. And when it hits that pause, it will also flush the graphics. So you can see that if I run this, now it runs at a little bit slower, chunkier rate because every 0.2 seconds it's waiting here and drawing the graphics. So again, that's another way you can force it to animate the scenario as it goes along. So this looks great here, but actually all we're doing right now is watching the flipbook occur one time on our screen, right? So this isn't exactly what we would like to do here because really we want to be able to save the flipbook. So let me go ahead and comment that out as well. And really what we would like to do is in fact call the function called getFrame. So getFrame, what it's going to do here is getFrame acts very much like draw now in the sense that it's going to force the graphics to render, but it will also return basically a bitmap or a matrix of all of the values of the current figure here. So in other words, it will grab what the current figure looks like and return that as an image object that you can save. In other words, it will grab one page of my flipbook. So what I can do here is I'll make a variable, maybe I'm going to call it movie vector. It's okay, gets getFrame. So movie vector is effectively going to be our flipbook. Maybe a better variable name should have been flipbook here. But what you can see is going on here, when I run this, every time it hits line 43, it's going to grab the current picture and jam it into this thing called movie vector. So by the time this loop ends, we should have an enormous thing called movie vector. So let's come back over here and come to the MATLAB workspace, and you can see, yes, that actually is the case here, right? You see you've got this 1 by 100 strut here. And in fact, I think if we look at the number of bytes this thing takes up, you'll probably get a better idea of what this thing looks like. So as you can see here, yes, movie vector is this enormous thing which is basically 100 bitmaps all saved together here. I think it saves it as some other object if you're really curious. Yeah, it's a strut with these things. Yeah, it's got a .c data field and a .color map field, but you can see it's basically a red, green, blue image here of 500 by 652 pixels here. Okay, so at this point, we've basically done steps 1, 2, and 3 here. So what are we on to now? I think it's step 4 was what, advanced time? Well, that's pretty much happens automatically at the end of this for loop, so we really don't need to do anything here, right? Do not need to do anything. All right, so now let's go ahead and drop out of that for loop, and now what we want to do here is step 5 here, where we want to save the movie. Okay, so now I've got this movie vector, which is all of my flipbooks. I really would like to print this out as an actual AVI or an MP4 file here, right? So the way to do that here is I'm going to call VideoWriter. So this is a class here which MATLAB uses to do a lot of video writing operations here. So the constructor for this is I just need to give it the name of the movie. So in this case, I don't know, how about curve? Since we're drawing the curve of this trajectory here. Okay? And then what I'm going to do here is let's go ahead and set this thing to a variable name. Maybe call it myWriter. Oops, writer gets. There we go. Okay, so at the end of line 50, we've basically created this VideoWriter object. And now what we can do here is we can go ahead and modify parameters of this. Like, so for example, maybe the frame rate. I want this the final movie to play at 20 frames per second. So I'll do that. Okay, so now that I've got the VideoWriter object set up and ready to go, what I can do here is I can open the VideoWriter object, write the movie, and close the file. That's my next step here. So I'm just going to go ahead and say open my writer. And then I can call the write video function here and just pass it the my writer, right, which was that VideoWriter object here. And then I have to pass it the flipbook here, right? So if you remember, right, the VideoWriter is just the object that's going to do the writing. It doesn't actually have the data. The movie vector is the actual data or my flipbook. So I'm going to pass it movie vector. So at this point, write video should know everything it needs to create that. So line 55 is going to actually generate the .avi file on my hard drive. And when I'm done, let's go ahead and close my writer. All right, so that should be the bare bones amount of code to get this working here. So before we run this here, maybe let's switch here to look at the current folder and notice here, yeah, there's nothing called .avi right now, but as soon as we run step 5, we should hopefully see something show up there. So here's our picture here. We're seeing the animation go through, and we're generating the flipbook right now. And then as soon as it finishes, we will write it out to a file. And there we are. There's a file called curve.avi. So if we come here to Windows Explorer here in that location, here it is, curve.avi. And I can just now go ahead and double click this and run it. And here's my movie saved in Matlab here, or sorry, saved as an AVI file on my hard drive. All right, now there's a couple of other options that we might want to look at here. So for example, there are different file formats. So I know not many people are comfortable with AVIs. A lot of people like MP4s here. So you can easily change your call to the constructor here of VideoWriter, and you could say, I want this to be an MP4. So if you just pass it an additional parameter in the constructor, the VideoWriter will now know that, hey, I need to be generating an MP4 instead of an AVI file. So if we run this thing again, it will actually work quite nicely here. So let's give this a second to finish here. And when it does, let's come over to our temp folder here. And you see, now there's a curve.mp4, which also should have a very similar set of information. So again, here's my animation running at 20 frames per second here. Great. One other last thing that I wanted to show here was actually, you can start doing fancy things like, for example, maybe let's make the viewpoint change here. So instead of just staying at a static viewpoint, we could go ahead and make this change. So maybe let's rotate the azimuth with, I don't know, something like this here, right? So what this is going to do here is the azimuth should start rotating around and around and around as we move. Now, if we do this here, you see that, yeah, this is looking pretty cool. So we still see the particle moving up, but at the same time, the trajectory is rotating around, or the viewpoint is rotating around. But now when we actually come to the video write portion, we see we run into this error here. What's ending up happening here is, again, Matlab, when you try to call getFrame, it tries to be intelligent about where to grab the frame here. And the problem here is that the movie vector, if we look at the first element of movie vector, you see that it's 515 pixels by 652 pixels. But a couple of seconds later, when the viewpoint has switched here, like here's at 10 frames later, you see that actually that's still the same here. Let's try a little further along. Nope, not that one. I should be able to find an example here where it's not the same here, because that's basically what it's yelling at us for. Wow, why am I having such a difficult time finding these? All look the same to me here. Whoops. Okay, there we go. Okay, so here. Sorry, maybe let me clear this. So what are we looking at? 97 here. So let me clear the screen. So movie vector sub 1 and then movie vector sub 97 here. So if you look here, that the height of these two images are not the same here, right? One has an extra pixel here. So basically what happened is getFrame decided to grab a section of the screen which was a little bit larger than what we wanted. So what I would like to do to fix this problem here is you can actually tell getFrame to only grab a certain number of pixels here. So in order to do that, what I'm going to first do is come back up here to the figure call here, and I'm actually going to assign a figure handle to this figure. So now fig H is going to refer to this single figure. So now when I come down here to getFrame, what I can do is I can say, all right, getFrame, grab Fig H here, and now I'm going to pass it a rectangle, which says, first I'm going to specify how many pixels away from the lower left corner do I want to start grabbing. So let's grab 10 and 10. So this is a little bit in, so 10 pixels in from the bottom lower left corner of the picture. And then let's grab, how about 520 pixels wide by 400, right? I'm just going to pick some number here. So there, if I do this and run this script now, we see that yes, we again get the situation where the entire viewpoint is spinning, everything's animating, but getFrame is only grabbing a very specific box that I've specified down there. And now that's going to ensure that the flipbook, everything has the same size. So when I come down here to my VideoWriter here, it will be consistent and all the pictures can be pieced together nicely. So if I come here to my curve.mp4, we should see here's my nice rendered animated situation where the whole thing is spinning nicely here. Great. So with that, I think that's mostly what we wanted to cover. Let's take a look here at a summary slide to recap all the things we discussed today. All right, so to summarize what we talked about today, we first started looking at just animation concepts and looked at how a flipbook is actually a really good analogy for the workflow that we're going to follow in Matlab. So that workflow we talked about next was really this basic 5-step process where first we generated some data, next we would draw or render the scenario at a given time, we would then take a snapshot of that scenario here, and then just advance time over and over and over until we were done with all of the frames of animation. And once we were done, the last step 5 was to go ahead and just save that movie here to your hard drive. And then the last thing we looked at today was actually creating an example script in Matlab using all of the different functions like getFrame and VideoWriter here to create an animation and actually create an AVI or an MP4 file on your machine. So I hope you enjoyed the video and it was helpful. If so, please subscribe to the channel. You should be able to do so using the link that should have just appeared on your screen, as we're going to have lots of other videos discussing other topics in Matlab and areas of interest. So I hope to catch you at a future video. Thanks so much. Bye.